Hello and welcome back to Making a Synthesizer in C. This is episode 8. So let me plug in my little keyboard and I'll show you what we made last time. So if I can get this to run. Run. Oh, has it not built? There we go. So we added polyphonic notes, so we can play chords now. So what I want to do in this episode is add in some modulation. We did already have a little bit of that in the very early episode. We had an LFO, but that was just hard coded in, so I'd like to get it working with the UI system at some point. So let's give that a go. Okay, so here's our code. So we do have in our update phase an oscillator function here, the ability to pass in frequency modulation, and that's just going to add modulation to this. So really what we want to do is have the ability to pair multiple oscillators. So maybe we need to create a new structure here called call this a modulation pair. And this is going to have a pointer to a modulator and a carrier. So that's what you call the oscillator that's being modulated by another one. That's called the carrier, and the thing doing the modulation is called the modulator. Then we'll probably want to have a modulation ratio, although I think in actual synth terms this is usually called a modulation index. But I'm not going to call it index here because that can be confusing in code, because usually index is like an index to an array. Yeah, modulation pair. Let's put you down here, and then we're going to have an array of these. So we're going to have modulation pair, pairs, and a count. So we're then going to have this in here. So we'll put modulation pair array, and then if we come down to our main, this is where we'll actually create it. So we're going to do modulation pair, modulation pairs. I don't know how many we're going to have, let's just do 256 for now. Modulation pairs equals dot pairs modulation pairs, I'll just call this data. And so then when we're calling update phase, update phase in osc, which is called here, we're going to have to how are we going to do this? So let's see, we're looping over each oscillator. And then we've got another loop here where we're looping over each sample in our buffer. So really what we need to do is I have a feeling, I think each oscillator is going to have to keep its own buffer. Maybe. Because then it gets complicated when you want an oscillator to be able to modulate itself, which, you know, in the real world, synthesizers can sort of loop back onto themselves and modulate themselves. So what I think we need to do is each oscillator needs its own buffer. The same size as the stream buffer size. Let me just check that. Still 514. Oh, I've called it the modulation pair array. Right. And then the count will be zeroed. So yeah, we've added the buffer. And so now in our update oscillator array, what we actually want to do is say osc array osc i.buffer. So we're not going to accumulate it yet. And then we'll have a separate function, accumulate oscillators into signal. It will take a synth. And then we come back up to here just so we can see what the synth is. You know, at some point we do need to change that. So at some point I want to put a pointer to each of these into their own array so we can easily loop over each type. Then when we're adding a new shape, we can just sort of specify it in one place in the code base, and then the rest of the code will automatically be updated. I might do that now. So it will become oscillator array. Call this oscillator groups, and then usize groups count. And then what we can do here is say for let me do that. So the oscillator array just has that and count. So we can copy that, can't we? We can say ask array equals synth oscillator groups I. And then we can just say ask array count. I'll keep this consistent here. And then for each of those, we then need to loop over the sample. Actually, in the last one I called it T, didn't I? So I'll call that T. And so now we actually update it. So we're going to say synth signal T is equal to oscArray dot osc buffer T, and that needs to be plus equals. So here we now do accumulate and we pass in the synth. So we can't loop this yet because we would then need to bind actually no, we can say we can move this up to the top here. And then this oscillator array here can have the wave shape. And this now becomes for just becomes this, right? Oscillator array, oscillator array, update, wave shape function. Now we need to actually populate that oscillator groups. Here in main. It's a pointer. Going to be 1, 2, 3, 5 of them. Probably what I'll have to do then is put you down here. And then you'd be address of synth sign-os synth And then wave shape fn equals, and if we come to our shapes, sawtooth shape, wave shape equals triangle shape. So let's see if this still runs. Cannot cast struct oscillator int 212. Oscillator ask. Buffer. Call that sample equals this, right? And then this becomes sample, right? So what's wrong here? Here's our oscillator array. Base shape function should be returning a float f32 times what's this at? What's wrong with this? Maybe we might have to start using malloc a bit. Cannot cast struct oscillator to int, but I'm not trying to cast it to an int, am I? Have I mucked up the wave shape function? F32 const oscillator. So base shape fn osc array dot osc I. So it doesn't like, oh no, got I here. So probably what we're going to have to do here is not pass in. Yeah, all right. I'm not going to pass in the whole oscillator now because that's a lot of data to pass in. And I guess it does want a pointer. So instead, it's just going to get 2F32. You're going to get I'm going to pass in the phase and a pointer to the phase delta, and then this frequency modulation here. Frequency. Call that frec mod. So then we'll set the phase. Oh yeah, there should be phase ratio. Set the phase ratio. So then this becomes so we probably then want and then the base osc shape function now just needs phase ratio, phase delta, and the shape parameter. So we need to change these are all cons, so 32 phase ratio, shape param, right? So we need to then change each of these to that. Let me copy all that. So that just becomes this. Same for the triangle. Oops. Square. and the rounded square. So now we can just do fx2 sample equals and then it just becomes phase ratio phase dt and ask the shape parameter 0. Oops, spelled sample wrong. Then we do sample times equals osc.amplitude ratio, and then osc.buffer t is equal to the sample. Ooh. 244 pointer expected. So let's make sure that this still works. It does not. We have broken it. So where have we broken it? We do have some warnings. Assignment makes integer from pointer without a cast. Assignment from incompatible pointer type. Assignment makes integer. So let's go to 563. Oh, we then need to set that in the synth.oscillator. Still not working. Oops. Maybe I'm not a fan of how I'm doing this. I'd rather just get rid of this, you know. And then I'm going to start using malloc for this kind of stuff. So what we'll do is we'll say the oscillator groups if I change that to max oscillators. So we want 5 times size of oscillator array. Probably won't work yet. I think we'll have to include standard lib for this. And then we'll just say like synth dot oscillator groups 0 is dot wave shape function equals sine shape. Do this 5 times. And one thing we could do is, but we do have that none there. We'd have to say something like that. So 458. So now we can make this something we can iterate. Synth dot oscillator groups I. So we it compiles, but we do get a problem here. So our next oscillator, which takes an oscillator array, do you have to like initialize this so it's more like this? Or like this? No. I probably do need to set the count to 0. So we're not getting the crash anymore. Oh, but we do when we go to sawtooth. Okay. So what have we broken? I might have to change our compiler because it would be nice to step through this, which unfortunately we can't do with TCC, the Tiny C compiler. It doesn't generate the correct debug symbols. Let's have a look. Update phase and ask. So we've got our oscillator array. Is it possible our accumulate isn't working? That should work. We do 0 the signal. Just to make this at 8. Oh, do I need to set our oscillator groups count? Or have I forgot to set that? I thought I did set that. Alright, that's working. But now we're back to I mean, that does not sound right at all. That is wrong. I'm trying to figure out what the problem with that is. Where did we go wrong? So for each of our oscillator groups, we're updating it and then we're accumulating it. So here's our ask buffer t. We're going from 0 to stream buffer size equals the sample. Is it possible we've ruined the phase? I mean, this can come outside of the loop, can't it? And then we can say this just becomes update phase because we're no longer passing in. This becomes more generic. Let me listen to that again. It's like it's missing. So there's our os array. Let me try and take a... Alright, hello, sorry, I had to go for a bit. I'm back now. Yes, so what I've done is I've installed, well, I've already got Visual Studio 2019 installed. So we're going to use the Visual Studio compiler to solve this problem. And the reason for that is the TCC Tiny C compiler we were using, that's cool, it's nice and tiny. Low footprint, but it doesn't generate the debug information we need to be able to debug our application. So I'm now switching to the Visual Studio compiler, which is called cl.exe. So you can see here, this is the new batch file for building with Visual Studio. It's not that much different. Like you can see here where I'm linking to Raylib, kernel 32 user, GDI, shell, winmm. It's the same as what I got in here, pretty much, just slightly different options. This OD here sets our optimization level, so in the future we could do O2, which would optimize the code, be a little faster, but for debugging usually want to set to OD. Yeah, same thing, we put in the synth.c file and it spits out a synth.exe. So I've got this bound to Shift F1, so you can see that's there. Ignore this warning. I might be able to turn that off somehow. And then another key, I can run it. So we were having an issue. We were trying to refactor the code a bit to prepare for modulation. But at the moment, it's not working. And I think sometimes it works. Let me run it again. Sometimes it spits out like a horrible noise. So what I'm going to do now is attach it to the debugger. So let's bring up Visual Studio. So we're just going to continue with our project, and we're going to bring in our synth.c code, load that, and then if we come up to here where it says attach, we can attach it to a process. So I'm going to click that. I'm just going to type syn to search for synth, and yep, synth.exe. So we're going to tell our debugger to attach to this. And cool. So let me resize this a little bit. So let me move this over to my other monitor, and I'm going to set a breakpoint in our handle audio stream. Here. Oh, but I want it to only do it once we're playing a note. So I'm going to hold a note and press quickly so we don't have to hear the noise. There we go. Okay. So now with these buttons up here, or with the hotkeys F10, F11 and Shift F11, we can step over code with F10, and we can step into functions with F11. Yeah. So for example, we're going to step into the 0 signal here, and you can see it's passed in a pointer. And so so we know this is an array of stream buffer size. So what we can do is if we come to watch here and we do signal, and we'll do F321024. Does it not let us do that? Don't think it lets us cast. To an array like that. But we can like index into it. So we could do like what signal 10. So at the moment it's all zeroed out anyway. So we're gonna step out of this. So the hotkey for that was Shift F11. And then I'm gonna step into this loop here where we are looping over our oscillator groups. So here's our oscillator groups. Oh, and just to clarify, when I was also switching out the compiler, I did make a few tweaks to the code. So now when we're creating a synthesizer, the synth object, we're using malloc for the whole synth structure. So that's just going to tell our operating system, Windows, to give us a chunk of memory the size of our synth structure. And then it's the same thing, but now I'm sort of setting it up this way. And all I had to change here was, instead of doing address of synth, I just now pass in the synth because it's already a pointer to a place of memory. So let me come back to our handle audio stream. So on this line of code, we get, so here's our oscillator array, and we can see it's we've got one oscillator because I just held down one key on the keyboard. You can see here it's got our wave shape function pointer pointing to the sine shape function. Here's our array of oscillators. It should be 32 of them, yeah, but only one of them set, which is in slot 0. So the frequency set 261. I think I played C, so yeah, that sounds about right. Our amplitude ratio.
Do you want to see me?
Oh, I'm okay, thanks. Yeah. So this, our buffer now is all zeros. Oh, it's not all zeros, there's some junk in there. So yeah, obviously because we haven't initialized, because we're using malloc now and we haven't initialized the memory, there might be some sort of junk values in this memory that we have to be aware of. But that should be okay because we loop over this entire buffer array and set each with data anyway. Okay, so let's step into this update oscillator array function where we pass in our function pointer to the wave shaper, the synth and the oscillator array. So here we're looping over each, but we're only going to do that once. We're getting a pointer to the specific oscillator in that array, so that should be the exact same. Yeah, same frequency 261. We're checking the bounds of the frequency, that should be okay. And then now we're looping over each sample in our buffer and applying it to the oscillator's buffer. So here we're updating the phase. I've updated this function update phase now to not take in an oscillator, but it takes in just the variables. So if we check now the oscillator, we should see the ratio and DT updated. Yep, they have. So let's see if the wave shape function works. We could probably step into this. Yep, goes up to our sine shape correctly. The ratio should be correct, and the DT shape param 0.5. Very good. So here's our sample. Yep, it should be between -1 and +1, and it is. And then we're going to multiply it by our amplitude ratio. That looks correct. And then we're going to apply it to our buffer. So the buffer now in the first slot should have that value. So if we let this loop run, let me put a checkpoint, let's move our execution to here. Let's check our oscillator array, oscillator 0. And the buffer should now all have values set. And it doesn't. Why is that? So it only has the first value set, and the rest is 0. With some junk in there still. So that's obviously wrong. So there might be something wrong going on in here. And now if we check our synth structure, let's have a look at synth. Let's have a look for our oscillator groups. So the first one, sine, and then for the first oscillator. Now if I look in here, the first value isn't even there. So, and there's still junk in there. So I think actually there's a problem with, and I think you can see it here. So we're not getting a pointer to the oscillator array. We're making a copy of the entire oscillator array. We're updating that, but obviously by the time we leave, it's we're not seeing the data that we've set in update osc array. So let's fix that. So let's come to synth. Let's come to update osc array. Oh no, it was the handle audio stream. So we actually want a pointer, and then that becomes an address of. And for our update osc array, are we actually using synth anywhere in here? No, so you can get rid of the synth. The wave shape function is now part of the Oscar array structure, so we can get rid of that as well. So this just becomes a pointer to an Oscar array. Now we have to change this to pointers. So that looks good. Just make sure Oscar array, let's have a look. Synth, wave shape function, Oscar array, count, Oscar array, Oscar array, wave shape function, why is it? I am. Uh, 271. Oh, we need to update this, so now we just do this. That's built. So let's give this a go. There we go, we're working now. Let's add another shape. Make sure our frequency sliders are working. And this one. Good. Alright, so we're back into our working state now, and with the help of our debugger, that's good. Let's now come back to what we were working on, which was this modulation pair. So, modulation pair array, let's make this just a normal array, so we'll say max oscillators for now. Just going to call this modulation pairs. So we come down to here, we'll do synth modulation pairs dot count equals 0. And let's give these like wave shape sign. We do have to -1 to each. Yeah. Just makes more sense. Oh. All right. So when we apply the UI state, let's handle this here then. So if we've got two oscillators, tell you what, let's just set it up here for now. So we got modulation pairs that count, synth modulation pairs 0 dot modulator is going to be equal to the address of the synth oscillator group wave shape sign osc0 and the carrier, and then the modulation ratio is going to be equal to 1. So that should still compile just fine, yep. And then if we come up to our handle audio stream, update oscillator array, what we need to do now is loop through our modulation. So we will need to pass in that. We'll need to pass in our modulation pair array. So that'll be the mod array. We don't need to do this inside the, we can do this when we put, so. Because you could have multiple modulators. We'll do it outside here for now, and we'll just assume that a carrier can only have one modulator, and then we'll look at refactoring that later. So let's do mod I equals 0, mod I mod array count, and then what we want to do is mod array data mod I. We want to check if the carrier is equal to our oscillator. So we'll say if and then what we'll do is modulation pair equals null. I'll just say 0 for now, and then we'll say our modulation is equal to mod array. Yeah. So now we need our frec mod, which is just going to be equal to 0 by default. But if we have modulation, then the frec mod, frequency modulation, is equal to whatever the modulator's buffer is. So it would be modulation modulator buffer t times the modulation ratio. So does that compile? Update oscillate. So now we need to pass in this mod array. So that should be pretty simple. It's just the synth. What did we call it in the synth? Modulation pairs. So now we've got our two sines. So I don't know if that's working. There is a bit of jitter there, so we might have to bump up our modulation ratio. So let's set this to 100. What did we say? We said the modulator was the first one and the carrier was the second one. So I can cut off the volume of our modulator. There's definitely something going on. And let's just make sure that our update phase, yep, that's using the frequency mod. So this is where we could step into this again. So what I'll do is set a breakpoint here. Let's launch our synth. Let's add our two oscillators, set U to 0. Should change U. Let's attach to the synth. Let's play now. So, if we have a look at our mod array, it says 1. And in index 1, we've got our first modulator and our carrier. And the modulation ratio of 100. So the carrier's frequency is set to 261. Yours set to 49, which I think we did, yeah. So mod I should be 0. And the carrier should be equal to us. But we probably have to let this loop through once. So right now we're on oscillator 0. So if I continue, we should now be on oscillator 1. And there we go, we found the modulation pair. And the modulator should have its buffer filled out, which it does. Although so yeah, I think the problem is we've got right, I think I understand, yeah, because we're also playing on module. What we want to happen is we don't want to actually accumulate. So in our accumulate oscillators into signal, we want to ignore modulators, basically. So let's do that. So we come up to accumulate signals. We basically want to do the same as we're doing here. For each oscillator. What we want to do is check if the modulator is equal to this. Let's just do so this can just then become and then this can just be a say skip osc. If we found this, then we'll say skip osc equals true, and then we'll say here if skip oscillator continue. And that should 271. Well, we're passing in the whole synth, aren't we? So we can just say synth.modulation pairs counts. So now, if I try and play this, oh yeah, of course, because if I play two notes, it's creating, okay. And then, so that's another thing we're going to have to handle. Is, okay, and then if I do this, there we go, so now we got Cool. So now, this is pretty fun. Now I need to figure out how to actually set this up in the user interface. So one thing we could do is we could have like a check mark to say this UI oscillator modulates the one immediately below it. Nah. I guess at some point I could like allow you to pick whip, like create cables between them and literally patch them. I think I might do that in another episode. For now, let's we probably want a second menu that says add modulator. Or let's have a look. Let's have a look at the Ray GUI. So we could do a button. Where am I going to put this button? Where's, oh, there's the delete button, defer. So what we want is a GUI button where do we want this? I might just put it here next to the X. So I'm going to create a new rectangle called our modulation button rect. Just copy the delete button rect for now, and then oh, that should be rect, not rexed. Get rexed. We're gonna this equals 50. I don't know. Yeah, too many A's. Make that 40. So when we hit this, we're going to cycle through the possible modulators. So this now needs to become our I'll just call this modulation pair index. Modulation state. So if it's 0, equals no modulation. Otherwise, it's the number of so by default it would be NA. And every time you click it, oops. UI ask modulation state plus equals 1 if UI ask modulation state is equal to, then now we need to can we do text format? Can that work? Char star and we'll say if the UI ask modulation state is equal to 0, then it's NA. Otherwise, it's this text format. Modulation button text. That should look good. There we go. And so now what we need to do is, it'd be cool if we could make this even lower actually. Notice it goes to 1. Maybe the frequency slider should actually go. Nothing's ever set that to -1. There you go, it goes to 0.1. All right. So now when we're setting up, we've got a modulation state. So now we actually need to set up our modulation pairs. So let me comment you out. You'll be 0. So let's have a look. For each UI oscillator, for each note, we need to set up the pair. So what we can do here is if UI osc modulation state is greater than 0, we kind of need to do that down here, don't we? Because then we need to do synth, oh, not here, synth.modulation pairs .count. And then the mod pair carrier is going to be equal to this oscillator mod pair dot modulation ratio. It's gonna, we'll set it to 100 for now. Problem is, how do we set the modulator? Because it might not exist yet, because we're constructing this, remember. Oh, don't forget, we do need to do synth modulation. Reset the count as well. So this should, in theory, should be equal to do if we only had one shape. Then it would just be like synth oscillator groups 0 dot osc UI osc modulation state -1, address of that. That even work? No, because we sort of need an extra parameter in our oscillator structure called that we can refer back to. Or that lets us know that this oscillator belongs to, yeah, so what I'll do is, yeah, I'll call it a modulation ID. Only has to be U8, right? I'll do U16. So our oscillator modulation ID is just going to equal our UI osc index. So we purposely set the modulator to 0 for now. And then we'd have to do another pass once we've set up all our oscillators. I'm trying to think how I can set how I want to go about doing this. Then I need to loop over all the modulation pairs, don't I? So I'll do for so that's equal to synth modulation pairs data modi. I think what we want here is the we want to store the modulation ID in the modulation pair. So we'll do mod pair modulation ID is equal to our UI osc modulation state -1. And then we'll use that to hook it up. So we'll then say our mod pair modulator would then have to loop over The other way to do this is to here, I think I know how to do this. Really what we want is an array where as we go through each UI oscillator, we need a pointer to the group. Now that I think about it, we might have done this wrong, because our modulator, we want our oscillators to be per note, so we've got polyphony, but really our modulators, like an LFO, doesn't need to be per note, and they are at the moment. So you could have one LFO that's modulating all notes. Yeah, but that would require us to rethink how we sort of present things in UI. Because at the moment, there's no way to say this is a modulator. We're saying this is a carrier. I'll leave it per note for now, and then I'll do a to do. So anyway, we want an oscillator array. UI to osc group. Actually, that needs to be a pointer. Is an array of pointers, right? Yep, so this needs to be max oscillators. Or I guess max UI. So then what we'll do here is UI to osc group, UI osc I is equal to this. And in fact, we don't need to do this switch anymore. Right, we can just say if UI osc.shape is greater than 0 and UI osc.shape is less than wave shape count, then this just becomes UI osc.shape -1. right? Yeah, like that. So now we can set this in here. We can say I think what we can do is pull U out now. We just loop over the modulation pairs and we just say the modulator is equal to our UI to osc group mod pair modulation ID and we just point to the first one. So copy this note here as well. We also need to do a check for let me clear that out. See if that compiles. 579. That needs to be address of. That needs to be address of. So come here. Make sure you're all good. Let's create a sawtooth. Right. So you can see that's now modulating the first from the first modulator. Now, if I do 2, it should do itself. Which, and if I did 3, it should crash, which makes sense, right? Because we don't have a third one, so we'll probably need a check for that. So we probably need to do a check for our UI oscillator count right here. And if our -1 is less than our synth UI oscillator count. So let's make sure that compile. Bring this back, create 2. Let's make the sawtooth. So the problem is when we play yeah, so we have a problem here now in that when we play more than one note, because only the first note in this oscillator is being a modulator, but all the other notes aren't. So we need to yeah, we're making a lot more trouble for ourselves by not having it so. Ooh. I'm thinking. All right. No, that won't work, will it? I was going to put in the note index. So are we... We're not using this modulation ID anymore, are we? So that can go. But we probably will need like a UI ID, which is literally what that was doing anyway. Yeah, so the osc UI ID is equal to UI osc I. Then we need to like loop over here, so we do usize count, right? And then we need to say if our is equal to our modulation ID, that's when we set it. So I think that's right. Let's give this a go. Should be really obvious if I but we still have the same problem. So what we could just do here is just say our let me get a pointer back because that's becoming a bit of a mouthful. Becomes our oscillator, and our oscillator amplitude just becomes 0. Trace off. Right, let's try this again. So we'll set this to a square wave. So we've got one bug here where our sine wave isn't coming through. But it is if I play 2 notes. Strange. But let me... when I do the sine wave, that's not, doesn't seem to be working. Let me make sure I try that again. So yeah, when I press 2 notes, it only works when I press 2 notes. And if I get rid of U, and now, something strange going on. Let me just check the logic for this. So going through each of the modulation pairs, I'm going through all the oscillators in that group. And then I'm checking to see if the UI ID is equal to the modulation ID. And if it is, I'm assigning the modulator thing is, we probably only want to do that for the first one and then break. Like, if U equals 0, then we assign it. this can be pulled out to here. You know what? I don't have to do that, do I? Because we've already got the modulation ID. We've already got the information. We don't need to construct this array. I can do oscillator array is equal to our synth UI oscillator mod pair modulation index ID. Dot shape. So we'll get the shape first. I'll call that the shape ID. And I'll just cast that to a U16 there. And then, like we did here, this would be our synth oscillator groups shape ID. -1. I believe I have a fly in the room. That's annoying. God, it's loud. It's a power fly. And then this just becomes oscarray, oscar. And now I can get rid of this. See if that compiles. Where have I still got you here? Don't need to do you. UI osct group. This can be hoisted out. All right, so let's check if this still works. Nope. So let's debug this. Synth. So I want in our apply UI state, I'm going to hold down 1 checkpoint. So let's have a look. So I'm going to look at the synth. Our UI oscillator count is 1. And it's set to 440, blah, 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 blah. So we come through here. Here it is. Our MIDI keys count equals so here's a problem. Our MIDI keys that count. Oh yeah. We have to loop through each of them. MIDI key is on 0. So it's going to take a while, but eventually we should hit No. Let me just watch the note index. Oh, no IDX. And we'll let that come to what? To 0. So is on says 0. But we do have the note number and the velocity in there. Let me try this again. Okay, now I've got the is on. So we're gonna get our oscillator. That's all good. Oscillator's not null. I'm going to set the user interface ID, frequency. So this should be 0. Oh. MIDI semitone 3. So here's our frequency, 523 Hertz. We're going to set that. We're going to set the amplitude ratio. We don't have any modulation. All right. So now for our modulation pairs, this should just loop over. Good. So all the logic there looks okay. So let's come to our update Oscar Ray. Come into here. Or rather, inside the loop. Yep. So we get the oscillator, the frequency should be set. This, and then we start updating the phase. Let's step into this. So the frequency looks all good. So it looks like our phase ratio just isn't being incremented. Like by the end of all this, you see here our phase ratio is pretty much the same. Which is incorrect. So why is that happening? because we are passing it by reference, by pointer. And if we did view, see, that works fine. And our phase ratio literally should just be phase if it's less than 0 plus 1, if it's greater than or equal to 1 minus 0, is that the problem? Using a plus equals there? Because that's fixed it. Alright. So let's put U to square. So you can see now, if I turn you off, sorry, you can hear the square. I'll just notice a bug with the UI here where if I set U to square and then back to sine, it changes the see that? This is at 101, that was at 38. And I think that's to do with the way we were adding and deleting things. So this doesn't appear to be let's come back to here, let's attach. And then let's come in here. So this is being called, here's a modulation, here's a modulation pair, modulation ratio. So the carrier is all set. Frequency, amplitude, so what's that, 143? And the modulator, so I think you can see we've got the same issue again where we don't want to set the, I'll come back to this, sorry. We don't want to do this because then we won't be able to hear it. So we might need another like a bool is modulator in here. So we'll just say like by default equals false, but then here I will say it's equal true. And then if we come up to our thing here where we continue into, oh, it was an accumulate, wasn't it? Or skip os can just be, well, this is pretty easy now. This is just is modulator. We don't need to do all that anymore. Oh, I'm still running the synthesizer. All right, let's give this a go. So that's wrong. So like already just the default case, we've regressed. Oh, but that works. That's working as I expected. So now we've got like a vibrato effect there. Cool. And if we change this to sawtooth, I make use of. So that's working nicely. So let's try adding so what if I make U modulated by the second one? So now this is playing. Interesting, I thought that would work. So it could make you never make you a square. Now we can make like an alarm. Or like a siren. Alright. Yeah, there's definitely still some issues with this, and I'm not a fan of the UI yet. Like the chain, being able to chain them isn't working. So like, say we want this modulated by number 3, and we want this modulated by number 2, this by 1. We get some so that works. And then if we come to number 2, oh, so the chaining does seem to work. Ooh. Ooh, interesting. All right. So yeah, there's some stuff we'll want to do for next time for episode 9. So we've done frequency modulation. We'll want to do amplitude and pulse, but we've got some bugs still. Fix bugs with UI and modulation seems inconsistent. And better UI for setting up modulators. It should be pretty good. I'm pretty happy with the way we're rendering signals. I'll get rid of that one. All right. Oh, better change this now that we are using Visual Studio 2019 compiler. Okay, yep, I'll see you for the next episode. Bye.